Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to do a topic in organic chemistry, of course, which is nomenclature of organic and our nomenclature of organic compounds. Today's topic will mainly be concerning the carboxylic acids, and this is a class of organic compounds, of course, which we are given under the functions of the under the functional groups, which we have discussed as an introductory topic. Of course, I'm going to put the link to the video in the description box so that those of us who have not gone through the content can be able to go through, and we can have one or two maybe discussions in the comment section. And for that case, welcome to our topic for today. I hope we shall enjoy the topic and also assist one another in improving the skills of learning these particular organic compounds. So carboxylic acid, as we have said, is another class of organic compounds which is actually produced by the oxidation of aldehydes and primary alcohols. So in as much as we have discussed about these different groups that I've mentioned, we are going to see that subjecting specific groups to particular conditions like oxidations, some kind of temperatures is going to lead to production of other kinds of products which might fall under the category of a class of these particular organic compounds. One of those examples of those products that can be produced is carboxylic acid, and of course this is achieved by the oxidation of aldehydes and primary alcohols. So we said that an aldehyde has got a functional group that has got a radical and a hydrogen at one point, whereby this one is known as a carbonyl carbon. So this one, this part of a functional group that we are demonstrating here that contains carbon bonded to oxygen using the double bonds is what we call carbonyl carbon. So we are going to see that this one appears in a range of functional groups that we have discussed in other videos. For instance, the functional group of ketones is made up of two different radicals. Of course, they can be the same, but for that case, let's represent the first radical as R and another one as R prime. So in that case, you see still that a carbonyl group appears in that particular section, the same way in which it appears in aldehydes. Now for carboxylic acid, its functional group also has got a carbonyl group which is attached to those specific groups like that. But we shall look at this particular case and try to see that there is a difference between the OH that we have seen as a functional group for alcohols, and also we are going to see that in organic chemistry, not organic chemistry that we are talking about, in organic chemistry, for instance, a water molecule consists of hydrogen plus the hydroxide ions that consist of a net charge of negative. So it is important for us to differentiate between the structural formula or this aspect of the carboxylic acid that appears here, and then take a note of this negative charge that appears in the, for instance, in the water molecule, and the OH group that appears in the alcohol. For that case, for carboxylic acid, I'm going just to give a small demonstration to give the difference. And then from the definition of acids and bases, we are going to see that an acid is a compound that consists of hydrogen as the only positive ion. So for that case, if we are going to give the functional group for carboxylic acids to appear like this. Then the hydrogen ion that is here is going to be the positive ion for the definition of an acid for this particular compound to hold. So in that case, we are going to treat carboxylic acid in that way. And then for a compressed formula for this particular case, I've deliberately split the two parts so that we can be able to differentiate between which part is and displace the aspect of a positive and a negative ion. So this is how the carbonyl carbon is displayed in organic acids. These are carboxylic acids. So as we go ahead, I hope we shall find the difference between, we'll be able to get the difference between the two so that we do not confuse. So we have said that carboxylic acids can be produced from oxidation of ethanol. And again, when we shall look at reactions, you will note that there is an acronym that we can use. It's a common acronym for that matter, that says oxidation is loss of electrons, where reduction is gain of electrons. Now, in the reactions, we are going to see which part of, on the reactant side and the products, which part of the reacting species and the products is gaining or losing electrons, and that one will give us a clear definition of what the term oxidation means. But in as much as oxidation is loss of electrons, now this pertains electrons, and reduction is gain of electrons, there's an aspect of oxygen as an element that is also going to give us a different definition of the term oxidation, whereby you find that addition of oxygen to a particular compound refers to a specific term, and the removal of oxygen refers to a specific term. For instance, I've shown the positive ions for this, that is for the hydrogen ion, which of course demonstrates or portrays the characteristic of an acid, as we have said roughly that an acid is a substance that contains hydrogen as the only positive ion. That's one of the definitions of an acid. So we are also going to see which aspect or characteristic of oxygen in the reacting species and the product species makes them to be regarded as an oxidizing agent, reducing agent. So I'll just give this simple demonstration for that, but we shall reserve the discussion for another topic. So I've said that carboxylic acids are produced from the oxidation of ethanol. Suppose I give an example of an alcohol. Ethanol is an alcohol. It falls under the class of alcohols that we have discussed in one of our videos. So this one produces this kind of an acid. So in the middle here is a process that is known as oxidation that is taking place, and we shall look at this in relation to what I've talked about, gain or loss of oxygen. So if we look at this is ethanol undergoing oxidation to produce what we call ethanoic acid. Or this one can be called as well as acetic acid. We're going to see the acetic acid. We mentioned in one of our videos that there are some terms which are known as IUPAC naming system. The IUPAC names and some of the common terms or the common names which are accepted by the IU and the community of scientists as the ones which are valid in naming of organic compounds. So for this case, the product which has been produced from the oxidation of ethanol or alcohol, an organic alcohol, is known as ethanoic acid, which falls under the category of carboxylic acid. So for that case, one of the ways in which we can achieve carboxylic acids as a functional group is through oxidation of alcohols. So since we were under the topic of nomenclature of carboxylic acids, we'll look at the general procedures that we have discussed in our videos for other functional groups. And start with maybe we can start with the suffix. The suffix, we said that for alkanes is N, alkenes is in, for alcohols is all, etc. So for the suffix for carboxylic acid is oic acid. For instance, the one that we have demonstrated is known as ethanoic acid. So for this case, the suffix or the ending for ethanoic acids is going to be oic acid. The parent name is the longest carbon chain containing carboxylic acid, and is as well derived from the alkane parent groups. So that is the parent name. This parent name is consisted in the longest carbon chain. That is of course derived from the alkane parent names that we have discussed initially for other compounds in our videos. So this suffix, in case there is also maybe a repetition of the functional groups that we talked about, we are also going to use the terms di for 2, tri, these are the suffixes, the prefixes for the functional groups, tri for 3, tetra for 4, etc. So that rule also holds for carboxylic acids, but ethanoic acid for unsaturated compounds. Now in this case, there is a unique case whereby you find that if it is unsaturated acids, unsaturated acids, this is a definition, this is a term that is defined from the term saturation and unsaturation. The case which you looked for single bonds and double bonds, carbon chains that we have looked at. So for double and triple bonds, carbon triple bonds, we call these ones unsaturated, and the first one, single bonds, carbon bonds, we call them saturated. So for carboxylic acid as well, the ones that do not contain a double bond, we are going to look at a unique way in which they can be demonstrated through the examples. So the numbering for carboxylic acids, we're going to demonstrate that one using the functional group that we had written. So we find that the functional group for carboxylic acid is this one. And this is a radical, which means other groups can be added from that particular point. So the numbering of these carboxylic acids begins at the carbonyl carbon that we had mentioned that exists in ketones, aldehydes, etc., and even in carboxylic acid, as we have seen. So in this case, the numbering begins from this carbonyl carbon, and names. Okay, some common names can be used as well, whereby you find that this oic. Okay, in its the formation of salts, of course, we are going to see that's a different topic. Let's look at the examples of some of the carboxylic acids that we can be able to name. Let me draw an example of carboxylic acid. And for this case as well, they have cyclic and acyclic molecules, which we are going to look at one or two examples. So let's look at this particular compound to see carbonyl group, OH, and then we have this substituted hydrogen at that particular point, and this is C3. So in this case, we have said that numbering begins at the carbonyl carbon, and we shall begin from this particular point. So we see we have a functional group for carboxylic acid, so definitely it's a carboxylic acid. So the numbering begins at this point, 1, 2, 3. This is the longest carbon chain. Of course, we do not have another carbon. It's a symbol to name. So, and then at carbon number 2, there is a substitution of hydrogen for, that's chlorine for hydrogen, and that is as 1. So we shall start with the substituent and name this one as 2-chloro. Is the only substituent that we can see. So we name as 2-chloro, and then the parent name for 3-carbon organic compound is propane. So we shall have propan, and then the ending of that one, the suffix we said it is oic, and then we add the word acid. So for that case, this particular compound is known as 2-chloropropanoic acid. So that is as simple as that. Of course, some of these compounds have the common names, and as we said, some of the common names are used, but we shall just reserve that one for another discussion. So let's look at another example of the carboxylic acid that we're talking about. Now in this case, we are going to see that there are some cyclic compounds that may be either aromatic or just cyclic or aliphatic, as we can say, and we are also going to see how they are named in that case. So suppose we have a compound like this. This is an aromatic compound, but it's actually known as benzene. We're going to see a class of organic compounds known as aromatic compounds, but that compound is known as benzene. But when it has a functional group, which is of carboxylic acid, COOH, then now it gets another name, and instead of this, now we are going to call it benzoic acid. Just a simple name as that. Benzo derived from benzene, and then oic is for carboxylic acid, and then that is a simple name for that. Now suppose this particular compound has got additional substituents, and then we see that maybe the carbonyl carbon, which is a carboxylic acid function, is attached at that point, and we've got bromine at that point and bromine at this point. Now for this case, according to line drawings of organic compounds, this particular point consists a single hydrogen each. So this bromine has substituted hydrogen, this one and this one respectively. So 2 hydrogens have been substituted from this point, the first one from here and another one from here, to get this particular compound. So for that case, in naming this compound, we shall start with substituents, and then if you look at the numbering of this particular compound, you will find that if we start from this functional group, this is 1, 2, 3, 4, 5, and 6. And then we use a different numbering format, maybe using that way. This will be 1, 2, 3, 4, 5, 6. You will find that either the one in green or yellow from the carboxylic acid functional group we shall have the numbers 1, 5, 1, 5. So if we follow either route, we shall have the same priority, which means that we can follow either routes in numbering of these particular substituents and come up with the correct name that we are looking for. So in this case, we shall have this compound as such, and then we can go ahead and name it. So there's 1, 2, 3, there's a 3, 1, 2, 3, 4, 5. There's a 3, 5 dibromo. Two bromine, two bromo groups, that is for substituents, benzoic acid. So this particular carboxylic acid is known as 3,5-dibromo benzoic acid. So let's look at another example. So if you can see at most of these compounds, you find that since the numbering begins at the carbonyl carbon, there's no need to include the one that we have been getting for other molecules like benzene. I mean other molecules like the alkenes and alkynes perhaps, because just one, they will always appear at the same time and the numbering will always begin at the carbonyl carbon. So let's look at another example. What if the cyclic compound appears as a substitute in a molecule that is regarded as an organic carboxylic acid? So let's look at this example. CH2, CH, there's an amino group attached at this point, and then there's a carboxylic acid functional group at this particular point. So if we look at this compound, you'll find that there's a benzene substitute attached at this point. There's an amino group attached at this point, and then there's a carbonyl carbon which forms a functional group for carboxylic acid at this particular point. So in that case, we're going to look to see how the rules still apply. And as we said, the numbering begins at the carbonyl carbon. So this is carbon number 1, number 2, and carbon number 3. We have said that this substituent is known as amino. This is an amino substituent. And now for this functional, this particular substituent that has been given here, the compound was, of course, we say that benzene, but when it is attached here, we can as well give us a different name, which I'm going to write. So for it as a substance, we give it the name phenyl. Phenyl, we're going to look in depth about that later, but for now, this substance name is given as phenyl. So when we are going to write the name, we shall write both, this is substituent 1 and 2 in alphabetical order, and then we shall have the name of that particular acid. So for that case, this is a 1, 2, 3 carbon compound. So it's derived from the parent alkane, which is propane. So therefore it's going to be propanoic acid. So let's see how that name will appear. So starting with the substituents, we shall have between the amino and the phenyl, which one appears first, in order of the alphabetical order, definitely to be the amine. So at what point of the carbon is attached? So this carbon number 2 of the chain. So it is 2 amino. Okay, the next substituent, 3 phenyl. Now we can do away with this. 3 phenyl. 1, 2, 3 propanoic acid. So the name of that particular compound or carboxylic acid is 2 amino 3 phenyl propanoic acid. Okay, we shall look at a particular example whereby the numbering does not include the carbonyl of carbon, and see how the suffix is given. But before that, we shall look at another example and try to give it a name. So let's look at this particular compound. So look at that particular compound. So there's a point that I had mentioned that we have priorities when we are giving organic compounds, and there are different functional groups that are appearing in this. So in this case, you can see that this one and this one is this one represents, actually when we were talking about the functional groups, this one is a carboxylic acid. And then you can see that this part here represents a ketone, and the last part towards my right. Okay, let me just demonstrate for this. So if you look at this part, for the functional groups that we talked about, this one represents an aldehyde. But for the second one that I'm going to show here, this one, this is a carbonyl carbon attached to this section of an aldehyde, of course another carbon to another carbon, and that one we gave it as name as a ketone, and this is an R group. From this point to the left is an R group attached to a functional group that is for carboxylic acids, this one of course. But for that case we are going to look at the preference, and we shall talk about that one later. So for now, let's just reserve this one for carboxylic acid and try to give it its name. So we shall learn about preference and priorities at some point in our discussion. But for today, let's just reserve that one for carboxylic acid and try to name that one. So we said that the numbering begins at the carbonyl carbon. This is the one, so number 1, 2, 3, 4. I've decided to follow this route because it forms the longest chain of this particular compound. So for that case, we shall go ahead and name. We identify the substituents. So in this case, the substituents we have first the 2 methyl groups. So we have methyl 2, and then we have, this one is known as an oxo. An oxo group is a carbon that is attached to this particular oxygen, and another one here. So for that case, we have 2 oxo groups. One is attached at carbon 3 and another one is attached at carbon 4. So what will be the name of this particular compound? So following the alphabetical order, M comes before O. So we shall write these two methyl groups here. So we have 2,2-dimethyl, 2,2-dimethyl, and then another substituent, 3,4-dioxo, 3,4-dioxo. So the number of carbons from the parent group, 1, 2, 3, 4. Butanoic acid. So the name of this particular compound is 2,2-dimethyl 3,4-dioxobutanoic acid. So we shall look at the last case which I mentioned, whereby the carbonyl carbon is not included in the numbering of this particular compound. And then we shall look at how the suffix is represented in this case and what name do we use for that. So for that case, I'll just draw the compound and then we shall go ahead and do the naming. So I have this compound here. So this is not joined, so it is just like that. So in this case, this is a carboxylic acid because it consists of that carbonyl group. But you can see that for the substituents, and much of it is out of that. So you will find that the numbering of that particular compound will start at the carbonyl carbon, and then we give the next substituent the lowest number. So we are not going to follow that route, we shall follow this one, 2, 3, 4, 5, 6. So since we have given the numbering as such, we shall go ahead and try to name it. The constituent groups that we are having in this particular case, I've said about the carbon oxygen. This is known as oxo. As a substance is known as oxo. And that one is known as the CHO. It's known as formyl. You write it correctly. Formyl. This is a formyl substituent, and this is an oxo substituent. Formyl and oxo. So in alphabetical order, the formyl will come first, followed by the oxo. So the name of the compound will be, and this is a 6-ring compound, which is a single bond, and it's an hexane. It's a cyclohexane. So the name will be 2, a substituent, which is formyl, another substituent, 4, oxo, and then the parent group is followed by the name cyclo-4, cyclic compounds. So it is 2-formyl 4-oxo, cyclohexane, carboxylic acid. Now we shall look at other examples of the similar nature, but when the numbering cannot include the carbon of the carbonyl, the suffix carboxylic acid is normally used. So this is hexane carboxylic acid. The suffix carboxylic acid is normally used. So this one be a single, just avoided using this space because it was not enough. So it is cyclohexane or hexane carbonate. This is a 2-formyl 4-oxocyclohexane carboxylic acid. It's a single name. This is a compound name, so for that case, let it not confuse us. So this is the nature in which it's named. We have seen on how to name carboxylic acid. Of course, there might be other additional rules that we need to follow, but for now, these are the basics that we need to comply with in as far as naming of carboxylic acids are concerned. So in that case, I thank you so much for being with me for this case. So I'd like to encourage us to subscribe more to our channel and also give your feedback on the comment section so that we can be able to have an engagement and have a healthy discussion. So for today, that is it. Thank you very much. Be blessed and bye.